Hello everyone. In this video I'm going to give you a couple of examples for how to use the sum and difference formulas. So we'll start out just by talking about what the formulas say. So let's look at the sum formula. What this says is that we can calculate the sine of the sum of two angles. So my first angle is U and my second angle is V. So I can figure out the sine of the sum of those two angles just by knowing the sine of U, the cosine of V, the cosine of U, and the sine of V. So I do it by first calculating sine of U, multiplying that by cosine of V, adding to that the cosine of U times the sine of V. So one way that I like to remember this is that we have UV, UV, with a plus in between, and it alternates between sine, cos, cosine. If we do U minus V, then the only thing that's different is that we have a minus sign in between sine U cos V and cos U sine V. Then, if I'm looking at cosine, I get cos cos, sine sine. When I add U and V, there's a minus in between the cos cos and the sine sine term. So it's cos U, cos V, minus sine U, sine V. When I do the difference of the angles U minus V, and I take the cosine of that, the only difference between these two is that it becomes a plus. So these formulas seem really abstract, and maybe it looks like the right-hand side is more complicated than the left-hand side. So we won't know. We won't be able to see how useful they are until we actually start using these formulas. So let's say I want to find the exact value of sine of pi over 12. Now, the exact value means in terms of a square root sign or something. It means we're not just doing it by plugging it into our calculator. We know the true value. And so the way that we're going to do this is to first recognize that we can write pi over 12 as the difference of two angles. So pi over 12 actually equals pi over 3 minus pi over 4. So we're going to be using this difference of angle formula where the U is pi over 3 and the V is pi over 4. Now, in order to use this formula, I need to know sine of U, so I need to know sine of pi over 3, cosine of V, so I need to know cosine pi over 4, cosine of U, and sine of V. So let's write down what each of those things are. So we have sine of pi over 3, which we know is square root 3 over 2. And we're also going to need cosine of pi over 3, which we know is 1/2. And then we'll need cosine pi over 4, which we know is square root 2 over 2, and sine of pi over 4, which is also square root 2 over 2. So let me just use some colors here. So first we're going to plug sine U in. This is sine U. And then cosine of U. And then we'll do cosine of V and sine of V. So we're just plugging into this formula. And it's quite simple now. So sine of U is square root 3 over 2. Cosine of V is square root 2 over 2. Minus cosine of U is 1/2 times sine of V is square root 2 over 2. So now I'll just simplify this out. Square root 3 times square root 2 is square root 6 over 4 minus square root 2 over 4 So I get root 6 minus root 2 all over 4 as my final answer. So I'm really just plugging into this formula where I couldn't solve for sine of pi over 12 using any of my special angles before. Once I wrote it as the difference of two special angles, now I could solve for the exact value because I know the exact values of sine and cosine for these two special angles. So let's see another way that I could use this formula. So now I want to find the sine of u plus v given sine of u and cosine of v. So I've got sine of u and I've got cosine of v. The information I still need is cosine of u, sine of v. So let's write down the formula. So I'm looking for sine of u plus v. So that's going to be sine of u times cosine of v plus cosine u times sine of v. And the values that I have, so sine of u I've got, and cosine of v I've got. So now I need to find cos of u and sine of v in order to plug into this formula. And to do that, I'm going to draw a triangle. So first, if u has sine equal to 4 over 5, then I can draw a triangle where the opposite is 4 and the hypotenuse is 5. And I could use Pythagorean theorem to fill in this adjacent side. It's going to be 3. So that tells me that cosine of u equals 3 over 5. And I just need to make sure that this should be positive 3 over 5. I'm given this information that u is between 0 and pi over 2. So it's in this quadrant, which means it should be positive. Now I know that cosine of v is negative 12 over 13, so it's part of some triangle, and it's between pi over 2 and pi, so it's part of some triangle in the second quadrant, where I have 12 in this direction and 13 in this direction. And I could use Pythagorean theorem again, and I would find that this remaining side is 5. So that tells me that sine of v, the other value that I'm looking for, is 5 over 13. And since I'm in quadrant 2, it's also positive. So now I can just plug into the formula. So sine of u is 4 over 5. Cosine of v is negative 12 over 13. Cosine of u is 3 over 5. And sine of v is 5 over 13. And since I'm doing the sum of these two angles, I add those products together. And I'll find that I have negative 48 over, let's see, that's going to be 65 plus 15 over 65. I add those together and I get 33 over 65 for my final answer. So I'm literally just plugging into the formula, but I needed to do a step beforehand to get these other two values, cosine of u and sine of v. So you'll practice using these sum and difference formulas a lot, and it will get a little bit easier as you practice more, but here are just two examples of how we can use them.